All right, so if we're coming back, hopefully you guys tried these problems. Again, direct substitution would have worked on this one, but we want to make sure, like, again, what happens if we can't use direct substitution, because it's not going to work on this one. So these are kind of basically the numbers that we should have come up with. And again, what we're going to see is what are we going to get the closer we get to 3, right? So 2.9, we're going to get 11.5. And then 2.99 is about 11.950, something like that. And then we're going to get 11.995. So it looks like I'm getting closer and closer to 3, or sorry, closer and closer to 12. Over here, I get 12.5. And then this is 12.05 and 12.005. So again, I'm pretty confident that my number is going to be 12. Now, please note that these examples that I'm giving you end up having a limit be an integer. Limits do not have to be integers. They can be decimals, fractions, and things like that. So just because it's 12 doesn't mean that 12.4 would not have worked. All right, as limit approaches 0 for this one, so x over x plus 9 minus square root, and then minus 3. So a negative 0.01 is about 5.998, so to speak. And then this is, as I get closer and closer to 0, I'm just going to be adding more 9s. So 99998. Again, who knows what happens when I plug in 0. And then over here, it's going to be 6.002, about 6.0002. And then 6.0002. So again, I'm pretty confident that this number is going to be 6. Now we are going to figure out, like, this is time consuming, right? So we don't want to necessarily make a table of points each and every time a limit does not exist. So we're going to come up with some other strategies in a later video. Okay. But we do have some properties and some basic limits that we can discuss, right? So here's our basic limits, and again, we can always use direct substitution, right? If it works. If it doesn't work, we have to come up with something else. So basic limits, right? So b and c are just real numbers, and we let n be a positive integer, right? So again, if the limit is just a number, as x approaches that number, then the limit's going to be b. So this means the limit as x approaches 3 of negative 2, right? This number will always be negative 2, right? Because technically this is a function. It's like saying f of x is equal to negative 2. So if I was to draw negative 2, here's my horizontal line. So it doesn't matter where 3 is. So here, let's pretend that that's 3. I know my output's going to always be negative 2. Okay, that's kind of what that means. For the next one, right, it says limit of x is equal to c. Again, this is kind of just falls back to direct substitution. So let's say the limit as x approaches 1 of x, right? What would this look like? So again, this is just a normal line, right, that's going to go through this value. So if I plug in 1 right here, what am I going to get out? I'm going to get out a 1. So again, that's just going to equal 1. As soon as I put exponents on it, then I can add exponents to my number. If I take the radical of those numbers, right, as long as n is even and my c is greater than 0, we're not going to see what's the word I'm looking for? Imaginary numbers on this one. All right. The next ones were a little bit harder to write out like this, so I'm just going to write them by hand. And these are properties of limits. Okay, and the same can be found. So if we have multiple limits, we can say the limit as x approaches c of f of x. We're going to call that one L. And then I'm going to say the limit as x approaches c of g of x. So new function. I'm just going to name it a different letter, k. All of these properties can be found in your yellow book on page 785. So if you don't want to necessarily copy them down or they're hard to read, you can always go back to that page. So we have something known as the scalar multiple So basically what this means is that I say the limit as x approaches c of a b value, something's being multiplied by my function. So if something's being multiplied by my function, that means my whole thing's being multiplied. So that means my b is going to be multiplied by my L. That's all that that means. Okay. I have sum and difference. So sum slash difference. And so basically this means that if I have a limit as x approaches c of my two functions, so f of x, and it's either going to be plus or minus my g of x, basically I'm going to take my L and I'm either going to add it or I'm going to subtract it to my k value. That's all that that means. Okay, so it's kind of basic knowledge. We have product. So the product basically says as a limit as x approaches c. So if I multiply these two guys together, that just basically means I'm going to multiply my L by my k. So LK. Quotient. If we have product, we should have quotient. So again, as the limit as x approaches c, and my two functions are being divided by each other, all that means is that my limits are going to be divided by each other. Here we have a denominator, so let's just remember that k can never equal 0, or whatever's on the denominator. And then last but not least, there's power. And so this one basically says this. So it says the limit as x approaches c. So if I have f of x and I raise all of this to a power of n, that just basically means my whole number is going to be raised to the power of n. Okay, so we could use those properties to help us with direct substitution. So let's go ahead and work on direct substitution. So direct substitution. Substitution. Okay, so basically I want you to find each limit. Okay, and if you want to pause the video, try a couple of these on your own. I'll put all of them up that we're going to do, and then we can you can pause it. So the limit as x approaches 4 of x squared, that'll be our first one, and then the limit as x approaches 4 of 5x, and then how about this one? The limit as x approaches pi, right, of tangent of x over x. So try these first three, and if you want to on your own. If you don't, no worries. We're going to work these out right now. So what would happen if I plug in 4? So 4 squared, that was easy, and that's just going to give me 16. So the limit as x approaches 4 of x squared is just 16. For this one, again, I'm going to plug it in. So I'm just going to say 5 times 4, and that gives me 20. And that is it. That's all we have to. Do. For this one, right? This will be the tangent of pi over pi. Now that we have to remember where pi is. So pi is down here. So on our unit circle, this would be your -1, 0. So technically, this will be 0 over pi. Anything divided by 0 is just going to be plain old 0. So hopefully you got those. Numbers. Okay. If you did not try those on your own and you want to try a few more easy problems, try these next 3. So how about we do another limit? So limit as x approaches 3 pi over 4 of, let's do another tangent of x. Let's do the limit as x approaches 16 of the 4th root of x. And then another easy one, the limit as x approaches -2 of x to the power of 3. So again, go ahead, pause the video, try these ones on your own. All right, if you're coming back from the paused video, here's what we're going to do. So again, we're just going to use direct substitution. So tangent of 3 pi over 4. So I have to remember that 3 pi over 4 is in quadrant number 2. That goes with the -√2 root 2. So technically, that will be -1. So that's my answer for number 4. 16, so this will be the 4th root of 16, I know that I can rewrite 16 as 2 to the power of 4. The 4s will cancel out, leaving me with 2. And then last but not least, I'm going to say negative 2 and then raise that to the third power. So basically that means I'm going to be multiplying it out 3 times. So this will be negative 8. So again, all of these are just direct substitution problems. Okay, and we can get a little bit more challenging, right? So let's try a few more. So that was number 6. This would be number 7. So how about this one? The limit as x approaches negative 1 of x squared plus x minus 6, and then 8. The limit as x approaches also negative 1. Actually, let's do not negative 1. Let's do positive 2. Change it up. So x is approaching positive 2 of x squared plus 5x plus 4 all over x plus 4. So if you want to try these on your own, be my guest. If not, we're going to walk through them right now. All right. So looking at number 7, I'm going to plug in. So this will be negative 1 squared plus negative 1 minus 6. So negative 1 squared is 1 minus 1 minus 6. So 1 minus 1 is 0. 0 minus 6 is negative 6. 2, this is a fraction. So this will be 2 squared plus 5 times 2 plus 4 all over 2 plus 4. So this will be 4 plus 10 plus 4 all over 6. So 4 plus 4 is 8. So this will be 18 over 6. And then 6 goes into 18 3 times. So our answer is 3. Okay. So that is your direct substitution. Those are your limits. As always, if you have any questions or concerns, please reach out to me and let me know how you're doing.